Question 2 on June 2021, paper 1. So question 2, only 3 parts. Part 1, define the mass number of an atom. So question 2, define the mass number of an atom. The mass number of an atom is the number of protons and neutrons in the nucleus of the atom. However, you will be allowed to just say number of protons and neutrons, but you need to make sure you say and neutrons. It's both. 2.2. Okay, let's get this out of the way. So 2.1 mass number of atom, number of protons and neutrons. 2.2 complete table 3 to show the numbers of neutrons and electrons in the species shown. So there's the number of protons. What's the number of electrons and what's the number of protons? We know they are going to be isotopes of each other, and isotopes have same number of protons, different number of neutrons. So to find the number of neutrons, it's going to be 46 minus 22. Neutrons equals 46 minus 22. And the fact that this is on A-level paper just shows you how they're going to test all your knowledge, not just the hard topics, also the simple topics like on the first topic on atomic structure. And for this, to calculate neutrons, electrons, you just need to know the method to do it. Well, it's not a really hard method, but if you've forgotten it, you're going to struggle to get these marks, these 2 nice marks. So it's 24 for neutrons for 49 Ti2 plus 49 minus 22, 27. And now to find the number of electrons, well, the number of protons and electrons are going to be the same. So it's the same as the bottom number, which is the number of protons. So 22 electrons here. And then you're like, oh, it's got to be 22 electrons here. However, it's got a 2 plus ion. 2 plus means that you've got an extra 2 plus charge. So what you have to do to the number of electrons is 22 minus 2. So you get 20. So the answer is 20 electrons. 24, 27, 22, 20. So find neutrons, 46 minus 22. Find the neutrons, 49 minus 22. Find electrons, same as protons. However, for this one, because you've got 2 plus charge, you're going to minus 2 electrons from your 2 number of electrons. So you get 20 electrons instead of 22. And then 2.3, sample titanium contains 4 isotopes. The sample has a relative atomic mass of 47.8. 47.8. Sample, the ratio of abundance is 2 to 2 to 1. Calculate percentage abundance of 46 Ti in this sample. So we know 46 we've got 46, 47, 48 and 49. Now the good thing about 46, 47 and 49 is we know the ratio. So we can just say that 47.8 equals 46 times by, let's not use 2x because you might get confused, say 2y plus 47 times by 2y plus 49. And because it's a 1 ratio, 2 to 2 to 1, it's going to be 49 times by y. However, we cannot forget the 48 one, 48 Ti, which is going to be plus 48 times by, well, what's it going to be times by? Well, we've already got 2y plus 2y plus y to give us 5y. And we know the total has got to add up to 100. So what we can say is 48 times by 100 minus 5y. Same for loads of these type of questions. 100 minus the number of x's and the number of y's you've got to find the final one. Over 100, and then now we can easily find 46 Ti. We just need to rearrange. Move this to the left hand side, so we get 4780 just times by 100 equals 46 times by 2y, 46 times by 2, 92y, 92y plus 47 times by 2, 94y plus 49y plus, that's times 48 times 100, so 4800, 48 times by minus 5 minus 240y. So we get, now there's a lot of terms here, so let's just take it step by step. So we got 92y plus 94y plus 49y minus 240y, so we get minus 5y plus 4800 minus 5y equals 4780 minus 4800 minus 20. Y is equal to 4. Okay, now we're not done, because we know in the sample the ratio of abundances is 46 Ti, 47 Ti to 49 Ti is 2 to 2 to 1. So 46 is going to be 2. 46 times by 2y. So what's the answer going to be? Well, it's just going to be 2y. Therefore, 46 Ti is equal to 2y. Therefore, 2 times by 4 is equal to 8. And therefore, the abundance of 46 Ti is 8%. I really struggle with these types of questions, because I'm just used to the normal relative atomic mass, calculate relative atomic mass, no x's, no y's, and you just put in the calculator 40 something to find, like 46 times by something, 47 times by something. They give you the values and you can find relative atomic mass. However, now I've seen these type of questions a couple of times now, maybe 2 to 3 times, where it's like involves algebra. So just exposing yourself to this, you will be prepared. Obviously, do a couple more of these. But just remember the ratio they give you, which is x and y, and then to find the final one, so in this case 48 Ti, what's the ratio of that abundance? Well, it's going to be 100 minus the total of this. So this is 5y. It's going to be 148 times by 100 minus 5y over 100. Manipulate and you get the abundance of 46 Ti. And that's the end of question 2.